Dear friends, today we are going to continue the lecture for electromagnetic induction. In the first lecture of this topic, we have introduced the concept of magnetic effect, magnetic flux and magnetic induction. In that we have studied units, dimensions and the basic formulae for magnetic flux and magnetic induction. Today we are going to start the first ever topic, important topic of this topic, electromagnetic induction, that is Faraday's law of electromagnetic induction, Lenz's law, and some important formulae related with this particular concept. So today's lecture is related with Faraday's law of electromagnetic induction. First of all, when we are going to discuss Faraday's law of electromagnetic induction, we must know what does it mean by electromagnetic induction. Electromagnetic induction. So what is electromagnetic induction? First of all, we must know every coil has a magnetic flux associated with itself. Every coil has magnetic flux associated with itself. When we introduce this coil in changing magnetic field, whenever we introduce this coil in changing magnetic field, the magnetic flux associated with the coil changes. Due to change in magnetic flux associated with the coil, an EMF is induced in the coil, and if it is a closed circuit, then along with induced EMF, due to induced EMF, and induced current is there in the coil. What we have discussed now, electromagnetic induction. Every coil has a magnetic flux associated with itself. Whenever we introduce this coil in changing magnetic field, the magnetic flux associated with the coil changes. Due to change in magnetic flux associated with the coil, an EMF is introduced in the coil. Whether circuit is open or closed, EMF will be definitely induced. But if circuit is closed, then this induced EMF will induce a current in the coil. This phenomenon of induction of current in the coil due to induction of EMF in the coil due to change in magnetic flux associated with the coil due to relative motion between coil and magnet is called as electromagnetic induction. The magnetic effect of electric current, we have studied that whenever moving charges are there, in Lorentz force we have studied, moving charges whenever come in contact with stationary magnetic field or stationary bar magnet, they apply a force on the magnet. Moving charges apply force on the stationary magnet. Here what we are doing, here we are considering moving magnet and stationary charges. A coil is there, stationary charges, stationary magnetic flux is there in the coil. Whenever a bar magnet is having relative motion with respect to coil, whenever bar magnet is having relative motion with respect to coil, this bar magnet applies force on the stationary charges, and due to that applied force on the stationary charges, an EMF is induced in that particular coil. This phenomenon of induction of EMF in a coil due to change in magnetic flux associated with the coil is called as electromagnetic induction. So I think that all of you have understood the concept of electromagnetic induction. Sequentially, what we are going to write, first of all, in electromagnetic induction, we are going to introduce the concept of induced EMF. Induced EMF. What is the cause of induced EMF? What is the cause of this induced EMF? The cause of induced EMF is change in magnetic flux. Induced EMF in a coil. What is the cause? The change in magnetic flux associated with coil. Why this change occurs in magnetic flux associated with coil? Due to relative motion between coil and magnet. If there is a relative motion between coil and magnet, magnetic flux associated with the coil changes. This induces an EMF in the coil. If it is open circuit, only EMF will be induced. There will be no induced current in the open circuit. But if it is a closed circuit, then it will also induce current in the circuit. And this phenomenon is called as electromagnetic induction. So my dear friends, electromagnetic induction is the phenomenon of induction of EMF in a coil due to change in magnetic flux associated with the coil due to relative motion between coil and magnet. So I am repeating this statement again and again. You can make note of this in your notebook. And now let us move on to the Faraday's law of electromagnetic induction. Faraday's laws of electromagnetic induction. What is Faraday's laws of electromagnetic induction? There are two laws associated here. Faraday's first law gives the cause of induced EMF. Faraday's first law gives the cause of induced EMF. According to Faraday's law of electromagnetic induction, what is first law? Whenever there is change in magnetic flux in a coil, there is induction of EMF in a coil. This is first law. What is Faraday's first law of electromagnetic induction? Whenever there is a change in magnetic flux associated with the coil, an EMF is introduced in the coil or induced in the coil. It means, what is the significance of first law of Faraday's law of electromagnetic induction? First law gives us the clarification about the reason why there is an induction of EMF in a coil. What is the reason? Change in magnetic flux. So Faraday's first law gives the cause behind induction of EMF in a coil. This is significance of first law. And second law gives how much EMF is induced in the coil. Faraday's first law gives the cause of induction of EMF in a coil. What is cause? That is change in magnetic flux associated with the coil. Again, there is another cause, that is relative motion between coil and magnet. So the cause of induction of EMF is change in magnetic flux. Then how much EMF is induced in a coil? That is given by second law. The magnitude of induced EMF, the magnitude of induced EMF is directly proportional to change in magnetic flux, rate of change of magnetic flux, directly proportional to rate of change of magnetic flux. So suppose that an induced EMF is represented by a letter epsilon, magnetic flux is represented by phi, and the rate of change of magnetic flux is represented by d phi by dt. Suppose that an induced EMF is represented by letter epsilon, phi represent magnetic flux, and d phi by dt represent change in magnetic flux. So an induced EMF is directly proportional to rate of change of magnetic flux. This is Faraday's law of electromagnetic induction. It represents both laws. One is why there is an induction of EMF, that is due to the change in magnetic flux associated with the coil. And second thing, how much EMF is induced? Whatever may be the change in rate of change of magnetic flux, that there will be a magnitude of induced EMF. So if there is a increase in the rate of change of magnetic flux, more EMF will be induced in the coil. If there is a decrease in the rate of change of magnetic flux, then there will be a decrease in the induced EMF. So now, if we want to write this equation in equality sign, we will have this constant here. And in laboratory, this constant comes to be 1. We are not going to prove it why it comes to be 1. We just have to consider that by experimental value, we have the constant is equal to 1. So finally, induced EMF is equal to d phi by dt. That is the rate of change of magnetic flux. We can also write this as phi 2 minus phi 1 upon t. This is induced EMF. As it is EMF, it is a potential. Its SI unit is volt. So this is general formula for Faraday's law of electromagnetic induction or induced EMF in a coil. We are considering this for one turn of a coil. Suppose that there are n turns of a coil. If there are n turns, then we will multiply this overall equation by n into bracket phi 2 minus phi 1 upon t. So this is general formula for EMF induced in the coil, and this is Faraday's law of electromagnetic induction. So what we have learned here, first of all, Faraday's first law gives us the cause why there is an induction of EMF, and second law gives us how much EMF is induced, that is magnitude of induced EMF. So according to Faraday's law of electromagnetic induction, we have this particular formula, epsilon, that is induced EMF is equal to d phi by dt. So induced EMF epsilon epsilon is equal to d phi by dt. For one turn, if there are n turns, then we will multiply it by n. So finally we have phi 2 minus phi 1 upon t. This is general formula for Faraday's law of electromagnetic induction. Also, we are aware with the fact that magnetic flux is equal to magnetic induction into area. So phi 1 is equal to, suppose that B1 A1 and phi 2 is equal to B2 A2, that is magnetic induction into area of the coil, then we will modify this formula as B2 A2 minus B1 A1 upon T. So this is general formula for Faraday's law of electromagnetic induction. Now, new scientist Lenz modified this for Faraday's law. Lenz has modified the Faraday's law. So how he modified Faraday's law? According to Faraday's law of electromagnetic induction, magnetic EMF is in. According to Faraday's law of electromagnetic induction, an EMF is introduced in the coil due to change in magnetic flux. So Faraday has given the cause behind induction of EMF. In the second law, he has given magnitude of induced EMF. So Faraday has given cause of the induction of EMF and magnitude of induction of induced EMF produced. Okay. But what is the direction of EMF induced in the coil? Suppose that the EMF which is induced in the coil supports the change in magnetic flux. Suppose that induced EMF, what is the direction of induced EMF? This is our now topic of discussion. What is direction of induced EMF? Suppose that EMF induced in the coil supports change in magnetic flux in coil. Change in magnetic flux in coil. Induced current supports change in magnetic flux. Induced EMF supports change in magnetic flux. So what we are considering here, the direction of induced current in the coil or induced EMF in the coil is in such a way that it supports change in magnetic flux associated with the coil. Now what happened here? If this happens, then induced current supports induced EMF, supports change in magnetic flux. So there will be a further increase in the magnetic flux in the coil. As there is a further increase in the magnetic flux in the coil, there will be a further increase in induced EMF, which again increases induced current. So what is happening here? We are getting induced current more and more on behalf of nothing supplying. We are not supplying anything here. There is just a relative motion between coil and magnet. Due to that, there is a change in magnetic flux associated with the coil, and EMF is induced in the coil and current is induced in the coil. But if they are supporting that particular cause which produces is, what is change in magnetic flux? It is the cause of production of EMF and production of current. Actually, it is cause of induction of EMF and induction of current. So if these two are supporting their cause of production, then this will again increase. It will again ultimately increase induced EMF. Ultimately, it will increase induced current, and the process will be going on, which is contradiction to the law of conservation of energy, because there is just a relative motion between coil and magnet, and we are not transferring any energy to particular coil. As there is a relative motion only, we are not transferring any energy directly to that particular coil, and there is continuous increase in magnetic flux, increase in induced EMF, increase in current, increase in charges. So we are not supplying any actual energy to the coil, and still we are getting more and more energy in the coil, and which is definitely contradiction to the law of conservation of energy. And this fact was observed by Lenz, and Lenz has given that particular direction of induced EMF. So if it supports, then that will be a contradiction to the law of conservation of energy. So according to Lenz, what is the direction of induced EMF? The induced current is induced in such a way that it will not support the cause which produces it. It will oppose the cause which produces it. And if it opposes, then that will be related to the conservation of energy. So what is Lenz given here? What is Lenz modified Faraday's law? According to Faraday's law of electromagnetic induction, he has given cause, he has given magnitude, how much EMF is induced in the coil, but he has not specified direction of induced EMF. According to Lenz, the EMF induced in the coil is induced in such a way that it opposes the cause which produced it. Change in magnetic flux is the cause which produces this particular induced EMF and induced current. So induced current is induced in such a way that it opposes the rate of change of magnetic flux, and this is actually Lenz's law. And according to this law, he modified this particular equation given by Faraday by giving negative sign here. This negative sign shows that induced EMF and induced current opposes the rate of change of magnetic flux, and this is actually the main equation for electromagnetic induction. And that's it for Faraday's law of electromagnetic induction and Lenz's law.